Hello everyone, this video is a part of EM Chapter 8 Arc Length, Area of Sector and Radian Measurement. This particular video is going to talk about Chapter 8.1 Length of Arc. The objective of today's lesson is to find the arc length of circle by expressing the arc length as a fraction of the circumference of the circle. Before watching this video, you should have covered the video that is found in the SLS lesson. In that video, you would have learned what is a chord, arc, sector, as well as segment. More importantly, for a sector, it is an area that is enclosed by any two radii and an arc, whereas for a segment, it is an area enclosed by any chord and an arc. Also in that video, you would have covered what is the formula for finding the length of an arc, which is the angle theta over 360 times 2 pi r. The angle is the angle subtended between the radius, the two radii that we are referring to, for that particular arc that we are trying to find. So we will move on to some practical applications of using this formula. In Practice Now 1, Question 1, found in your textbook page 249, we are given that O is the center of a circle of radius 25 cm and the reflex angle AOB is 228 degrees. I hope that you remember what is reflex angle. Reflex angles are angles that are more than 180 and lesser than 360. Therefore, it is this larger angle on the outside of AOB. In part I, we want to find the length of the major arc AYB. The major arc AYB refers to this. So using the formula that we have covered, we will take the angle subtended between the two radii, so 228 degrees over 360 times 2 pi, the r would be the radius 25 cm. Hence our answer should be 99.5 cm in 3 significant figures. Moving on to part 2, we want to find the perimeter of the minor sector OAXB. OAXB refers to this sector over here. And this sector comprises of 3 different sides, the arc length AXB and also the two radii which are 25 cm long. So to first find out what is the arc length AXB, what we can do, instead of finding the angle, the obtuse angle AOB, we can take 2 pi r, the circumference of the entire circle, minus away the arc length that we have found in part I. So this is what I have here, which is referring to the arc length AXB. Then we will add up the two radii, which is 2 times 25 cm, and we achieve the answer 108 cm. Next, we take a look at question 2, where we are also provided a figure and O is the center of the circle of radius 9 cm and angle AOB is 150 degrees. Typically, when they do not mention the word reflex, we will always take the angle AOB as a smaller angle, which in this case is an obtuse angle. So you need to note the difference when the question actually specifies it differently. So we want to find the perimeter of the shaded region, giving your answer in the form a plus b pi, where a and b are rational numbers. Rational numbers are actually numbers that can be expressed in a fractional form. So for example, m over n, whereby m and n are actually integers. So to find out what is the perimeter of the shaded region, we also need to find out what is the arc length. Specifically, it will be the major arc, and then after that we add up the two separate radii, which are 9 cm. So what we can do is to find out what is the reflex angle, which is 210 degrees, followed by finding the major arc length by using the arc length formula, and that will give us 21 over 2 pi. The reason why I leave it in terms of pi is because the question wants it to be in terms of pi at the end for the answer. So you should not be pressing into the calculator for the entire expression. What you could press into the calculator is 210 over 360 times 2 and times 9, ignoring the pi. Following from there, we will get the perimeter of the shaded region, which is the two radii 9 cm plus 21 over 2 pi, and we get the answer 18 plus 21 over 2 pi cm. We will now take a look at question 3, which shows the design of a logo in which a sector has been removed. The part that has been removed is this one where there is a dotted line for the arc. So given that the length of the major arc PXQ is 36 cm, and also angle POQ is 50 degrees, we want to find the value of R, which is the radius of this circle. So what we need to do is to first find out what is the reflex angle POQ, and that will be 310 degrees. Then we form an equation using the arc length formula and equate it to 36 cm, which is the arc length of the major arc length PXQ. So we then simplify our answer and get the value for R to be 6.65. We now move on to practice now 2 question 1 found in your textbook page 251. We are given this figure over here where O is the center of a circle of radius 8 meters. The points P and R lie on the circumference of the circle and OPQ is a straight line. Given the angle QOR is actually 36.9 degrees and OR is perpendicular to QR, we want to find the parameter of the shaded region PQR. So the shaded region comprises of 3 parts: the arc length PR, the side PQ, as well as the side RQ. To find the arc length of PR, we will apply the arc length formula and we achieve a truncated 5SF value, which is 5.1522 meters. Next, we proceed to find out the length of QR by observing the fact that triangle ORQ is a right-angled triangle. So we will apply Tuakaso. In this case, we will take tangent 36.9 degrees equals to the opposite side QR over the adjacent side 8 meters. So QR will be 6.0065 meter in truncated 5SF. Then we will also similarly apply the Tuakaso formulas that we know, okay, to find out the length of OQ. So we use cosine 36.9 equals to 8 over OQ, and hence OQ would be about 10.003 meters. Do take note that OQ is not what we want to find the parameter of the shaded region. We need to find out the length of PQ. So the length of PQ is 10.003 minus the length of OP, which is actually the radius of the circle, 8 meters. So we have PQ to be 2.003 meters. Now that we have found the length of the 3 different components for the shaded region, we will sum them up to get 13.1617, and when rounded to 3SF, we have 13.2 meters. I will be skipping practice now 2 question 2 and take a look at practice now 3. You may continue with practice now 2 question 2 on your own, at your own free time. Now let us take a look at practice now 3, where we are given that PAQ is the minor arc of a circle with center O and radius 35 cm. So I want you to be able to see that PAQ is this arc here, and O is the center of that particular sector. The radius 35 cm is actually for OQ as well as OP. That makes triangle OPQ an isosceles triangle. And when we have an isosceles triangle and we draw a perpendicular down, this makes OQR and ORQ congruent triangles to each other. Continuing with what the question gives, PBQ is a semicircle with PQ as its diameter. Then R is actually the center of this semicircle. Triangle ORQ is a right-angled triangle with angle ORQ to be equals to 90 degrees and angle RQO to be 36 degrees. So in part I, we want to find the length of PQ. The length of PQ comprises of 2 segments, PR as well as RQ. So what we can first do is to find the length of RQ, then multiply it by 2 because, as I mentioned earlier, triangle OQR is congruent to triangle ORQ. So cosine 36 degrees equals to QR over 35 can be applied to the right angle triangle OQR. Then we will get that QR is the 28.315 Hence, PQ will be double of that, which gives us the answer 56.6 cm. Now in part 2 of this question, it asks to find the perimeter of the shaded region. The perimeter of the shaded region comprises of two parts, which is the arc length PAQ as well as the arc length PBQ. So earlier on, if I want to find out the arc length PAQ, I need to rely on this angle POQ because PAQ belongs to this sector. Hence, to find out what is angle POQ, it is actually going to be double of angle ROQ. So angle ROQ can be found by doing angle sum of triangle such that we get 54 degrees. That means that angle POQ would be 108 degrees. Then using the arc length formula, we will get 65.973 cm in truncated 5SF. Next, we need to determine the arc length of PBQ. Because PBQ belongs to a semicircle, semicircles have an angle is subtended by angle 180 degrees. Otherwise, we can see as half the entire circumference of 22 pi times 28.315. So where did this 28.315 come from? This came from the value that we got in part I about the radius RQ for the semicircle. So we have 88.954 cm as the arc length of PBQ. Following from there, we add up the two different arc lengths and get the final answer to be 155 cm in 3SF. In the next section of this video, I will be going through exercise 8A found in your textbook page 254 to 255, questions 6, 7A, 11 and 13. You may want to pause the video now and give them a try before watching the explanation. We will now move on to exercise 8A question 6, where the question talks about a piece of wire that is 32 cm long is bent to form a sector of circle of radius 6 cm. We want to find the angle subtended by the wire at the center of the circle. To answer this question, it may be helpful to draw out a diagram to understand the question. Because the piece of wire is used to form a sector, so let us draw a sector of a circle. Okay, it may look something like that. So in this sector of the circle, it actually comprises of two radius as well as the arc length. The radius is given to be 6 cm each. So the 32 cm of the wire is actually part of, it is due to 6 cm of radius as well as the arc length. So we can form an equation out of that. We will let the angle that we want to find to be x degrees. So the arc length is actually 32 minus 6, which is 20 cm. Then we form an equation using the arc length formula, x degrees over 360 times 2 pi r, where r is the radius 6, to be equals to 20 cm for the arc length. By manipulating the equation, we will eventually get x degrees to be 191.0 degrees to 1 decimal place, since x is an angle in degrees. In exercise 8A question 7, we are given a circle as shown and we want to find the radius of it. We are also given that the perimeter of the minor sector is 77.91 cm. So the perimeter comprises of three parts in total, where 2 parts is actually the radius, and then after that the arc length over here, AB. So we can let the radius be RCM, and then after that we form an equation using the arc length, which is 148 over 360 times 2 pi r, plus the other two radius, and they should all sum up to be 77.91 cm as given in the question. We simplify the equation and then we factorize out the r value, and we get r times 37 over 45 pi plus 2, which is equals to 77.91. We then divide 37 over 45 pi plus 2 to the right hand side, and we will eventually get the radius to be 17.0 cm long. We now take a look at exercise 8A question 11, where there is a figure showing a circle with center O and radius 26 cm. Triangles OPR and OQR are congruent, and also angle OPR is equals to OQR, which are 90 degrees. Given that angle POQ is actually 138 degrees, we want to first find the length of QR. So QR refers to this length here. To find out the length of this QR, we need to see that because OPR and OQR are actually congruent triangles, we will be able to tell that angle ROQ will be 138 degrees divided by 2, so we get 69 degrees. Then, because there is a right angle at OQR, then we can see that triangle OQR would just be a right angle triangle, and hence we can apply to our castle and get tangent 69 equals to QR over 26, because OQ is actually 26 cm since it is also the radius of the circle. So QR will be none other than 67.7 cm when rounded to 3 significant figures. Next, in part 2, we want to find the perimeter of the shaded region, and the perimeter of the shaded region comprises of 3 parts, which is the arc length PQ, the length PR, as well as the length QR. So as mentioned earlier, triangle OQR and OPR are congruent. That would mean that PR is actually of the same length as QR. So let us first find the length of arc PQ. So that can be done by using our arc length formula, and we get 62.622 cm. Then, because in part I we have already found the length of QR, we simply have to multiply it by 2 to include PR itself. So when summing the arc length and also the sides PR and QR up, we will get the length 198 cm, or rather we will get the value 198 cm for the perimeter of the shaded region. Finally, we will take a look at question 13 in exercise 8A, where we are given this figure, and ABD is the minor arc of a circle with center O. Okay, so the center O is actually here. Alright, so ABD is the outer arc. Then after that, ACD is the minor arc of a circle with center P, which I have actually bordered it out in red already, and that radius is 16 cm. The radius of the previous arc is actually of 9 cm. The point X lies on AP such that AX is equals to XP. So we get these two equivalent lengths here. We want to first find out what is the angle APB. The angle APB is this length here. Sorry, this angle here. So to find out what is this angle, we will place our focus on the triangle AOP. We do know the length of AO, which is 9 cm, and the length of OP, which is 9 cm, because they are all radius of the bigger circle outside. So the next question would then be the length of AP. Okay, the length of AP is actually the same as the length of PD, because AP is the radius for the sector ACD, which is what I have already drawn out earlier in red. So this part here is 16 cm. So now that we have all this length for the triangle AOP already, we can apply cosine rule to achieve the angle APB. So using our equation, or rather the formula, we will achieve this equation, and cosine angle APB will eventually be 8 over 9. Then by taking cosine inverse, we get the final answer to be 27.3 degrees. Next, we move on to part 2, where we want to find out the angle AOB. So angle AOB refers to this angle here. And to find out what is that angle, because triangle AOP is an isosceles triangle, we can actually, earlier on, we found that this angle here is actually 27.266 degrees. So this will actually be 27.266 degrees as well, because it is isosceles. Isosceles because AO and OP, they are radius for the circle. then we can find out the angle that we want, angle AOB, by considering exterior angle of a triangle. That would be 27.266 degrees times 2, okay, because they are the same. So we get 54.5 degrees as our answer for part 2. Lastly, in part 3, we want to find the perimeter of the shaded region. The shaded region comprises of two segments, okay, or rather two parts, which is the arc length of ABD as well as the arc length ACD. We will now first take a look at finding the arc length ABD. To know the arc length of ABD, the center of this sector is actually at O. So that means that we need to know the angle of AOD. Since in part 2, we have already found out the angle of AOB, which is 54.532 degrees, we simply have to times 2 in order to achieve angle of AOD. So that will be 109.064 degrees. Then using the arc length formula, where the radius is 9 cm, we will get the arc length to be 17.131 cm. So this is the first part of the question. The next part of the question, we will need to find out what is the arc length ACD. So the arc length ACD requires the angle APD. And the angle APD would be 27.266 degrees times 2, because this angle that we have found in part I, which is angle APO, is 27.266. Okay, so let me correct this to write this clearer. This is actually angle APD. That will be 27.266 times 2, which will achieve 54.532 degrees. Then using the arc length formula again, we get the arc length of ACD to be 15.228 cm. Now that we have achieved the two different arc lengths, we will sum them up to get the final answer, 32.4 cm. We have now come to the end of today's lesson. Please kindly complete exercise 8A found in your textbook, question 2C, 3B, 5, 8, 10 and 15. The deadline for this homework is on Wednesday, 24th of June. Thank you everyone. I hope you have a good day ahead.